All right, hey, so this is going to be assignment p17.5, which is a PHET lab on refraction of light. And haven't even looked at it, so it could be just as bad as the last video. We'll see. We'll see. So but the idea is we're trying to at least get a feel for and an understanding of how light bends from one when it travels from one medium to another. So from air to glass, from glass to air, from glass to plastic, from plastic to glass, from air to water, from water to air, all those kind of things. The light is going to bend as it moves through the barrier from one medium to another. And so we'll click this, and that'll open up our PHET lab. And then we'll go back to our instructions. It says open the bending light PHET simulation and select the More Tools lab. More Tools. Got to click it twice. Once we'll select it. Okay, we did that. And set the we want to go. All right, so we are setting parameters here. I should open this with Cami so that I can write on it, because I can't write with the tools from the in our thing here. All right, so, see, now I can write. Look at that. Undo, scroll up. All right, so these are the parameters we're looking for. And this isn't the best laid out thing ever. That's what we're looking for. Medium 1 is going to be air. Medium 2 is going to be water. Laser view is going to be ray. A white wavelength we want 650 nanometers. Normal line enabled and angles enabled. So that's what we're going to do. Here we go. Material 1 air. Material 2 we're going to change this to water, like that. And let's see. Close that. I can't close that. Okay, I want to get that. There we go. Okay, so angles. So the normal line, this right here, this is the normal line, this thing. And that is the line perpendicular to whatever you're working with. Perhaps you remember it when we were doing inclined planes and calculating how much gravity is pulling something down an inclined plane and all that stuff. All right, so anyway, back to here. What do we want? 650 nanometers. Laser view is going to be ray. Where do we select that? Let's see where to select that. Move this out of the way. Do not see where to. Oh, right there. Okay, good, excellent. Okay, so now what does it want us to do? Using the protractor tool in the toolbox, turn on the laser source. Measure the angle of incidence, I. The angle between the normal. Okay, so this is where the part where I definitely want to be walking you through things. Okay, so we're going to go like this. Going to go like that. So what we have here, we always measure our angles off the normal line, and this is the angle of incidence. This is the angle of refraction, and we have a protractor that we can take out and measure, but we have measurement enabled there for us, so we don't actually need. We could disable angles, but we'll keep those angles enabled. All right, so we've got an angle of, what's this called? Incidence, and this is called the angle of refraction. All right, so the angle of incidence. Oh, and we got an angle of reflection too. Okay. So this here is the angle of reflection. Now, I will tell you right now, the angle of incidence and the angle of reflection are always going to be the same. Okay, so we got 45, 45, 32, right? So here we go. We're going air to water. 45, 40, reflection, that's 45, and refraction, that's 32 degrees. And now we're that says air to water, right? Now we're going to go water to air. We're just going to switch those around. And we're going to say, okay, now this is going to be water. Notice that there is no refraction or reflection, even though it's going from water to water, because it's the same material. And obviously you can't just put water next to water, but you can sandwich glass together. Here we go, water to air. We'll put air on the bottom, which we don't normally get to do we? All right, so there's our angle of reflection, and our angle of refraction is 70.4. So that is 70.4. That's 45, and that's 45. Use the speed meter in the toolbox to measure the speed of the incident ray, the reflected ray. Oh, we should have done this before we switched them. So we want the speed of all those rays. All right, so I'm going to, we might as well do the bottom one first. Where's our speed meter? There's our speed meter. Okay, so that's 0.75 C. Point C is the speed of light, so that's 3/4 of the speed of light. That is in air. So that's 1 times the speed of light, which is the speed of light. And that's 0.75 again, C. Okay, so that is the speed of the incident ray is 0.75 C. That's the reflected ray is 0.75 C. And the refracted ray, which is refracted into the air, is 1.0 C. Do you think it's going to be the opposite? I think it is, but we'll check it. Air to water. Yep, there's 1 C, 1 C, and 0.75 C. So that's interesting, isn't it? So if we're in air, that's going to be 1 C. I'm going to run out of time here in about 4 minutes. 1 C, and that's going to be 0.75 C. Okay, so we already did number 6 because we used water as the first. They already had, that's not the best laid out thing ever, is it? All right, guiding questions. What happens to the light from the laser when it strikes the boundary? Part of it reflects, part of it refracts. What relationship exists between the angle of incidence and of reflection? They are the same. How does light bend when it travels from air to water and water to air? You got to go back and look at that. There's air to water, so it bends when it goes from a less dense medium to a more dense medium. It's going to bend toward the angle of incidence, and when it goes from now I'm going water to air. When it goes from a more dense medium to a less dense medium, it's going to bend away from the angle of incidence. And the hint here about what's going on is the fact that it's going slower, light goes slower through water than it does through air. Okay, now they're giving us some other parameters. Air, water, that's the same parameters, right? 650 nanometers. That's exact air, water, ray, that's the same thing. Okay. Turn on the laser, measure the angle of incidence angle. Okay, we did it right. Okay. Increase the angle of incidence by moving the laser away from the normal. Observe what happens to the refraction. So here's what you're going to do. Remember that this is the normal line, right? So they're saying, watch what, I'm going to move this back to air and to water, because that's what we're used to seeing, right? By the way, this line right here, that's why it looks like, for instance, a straw bends when it goes into a glass of water. So if I take this and I move it more toward the surface of the water, what do you think is going to happen to the angle of refraction, this one down here? It gets bigger, but not that much, right? Look. And then as I go, it's always bending, always bending toward the normal, right? And again, I've got 2 minutes left. So you can use the protractor to measure, or you can just leave the angle measurement on and it will tell you. I would suggest at this point you just leave the angle measurement on. Who cares if you can use a protractor on a computer screen, right? So now you're going to have to find the sine of the incidence of, so So, okay, I'll just do the very first one here, because what we're looking for is some sort of, there's a law that we're going to discover here. So I'm going to make that 45. Okay, so angle of incidence, the angle of incidence is 45 here, and the angle of refraction was 32, right? Woo, 32. So now you need to put sine of 40, what is the sine of 45 degrees? That's what you're going to put there. You're going to calculate the sine of 45 degrees and put it there. That's the bell that says I have to go sine 45 degrees. That should say 45 degrees equals, and that's going to be sine of 32 degrees equals. So you're going to do that, and you're going to pick 4 different angles here, this way, and then you're going to calculate these numbers, and then you're going to switch it around to air to glass instead of air to water, and you're going to find out it's going to do something slightly different. There's air to glass. Notice it's similar, but this angle of refraction is actually a little more toward the normal line. There's a more refraction going into glass than there is to water, which I think is interesting. So you're going to do that with 4 angles here, right? And then measure this, and then calculate the sine and the cosine. You don't have to use a spreadsheet unless you know how to. That's fine. And then fill that in. Let me just see here. Pause. Pause. All right, someone's at the door. I'm going to finish this up. Okay, so they wanted you to use a spreadsheet and then make a graph. But you can just plot those on a piece of paper and make a graph and see what happens as you plot the sine of the angle of incidence and the sine of the angle of refraction. And then it just gives you a chance to draw some conclusions. And that's all I got to do. Thanks, bye.